Okay, so far we've solved quadratic equations two ways. Okay, first of all, what's a quadratic equation? Highest power is 2. What's the first way we solved them? You had to factor it, set it equal to 0 and factor, right? Then what's the second way we solved it? Graphing, you figured out where it touches the x-axis, agreed? Okay, there's a third way that you can solve these things. Okay, but it involves radicals. Now, you don't know what to do with radicals yet, so I have to teach you what to do with radicals. So it's a prerequisite today, meaning today is just stuff you need to know to do this last way. Does that make sense? Then tomorrow we'll get into that way called the quadratic equation. Just for the sake of time, I'm going to go ahead and forego these for right now. Let's talk about what perfect squares are. Does anybody know what a perfect square is? Yep. Correct. So what happens when you take the square root of it? A whole number. It's a whole number. Okay, so a number whose square root is whole. That's a perfect square. Okay, a number whose square root is whole. So we're going to list the first 15 perfect squares. What's the very lowest perfect square? No. 1. Because what's the square root of 1? 1. Okay, what's the next perfect square? It is 4. Because what's the square root of 4? Okay, what's the next perfect square? 9. So this is the third one, right? What's the fourth one? Now notice what's happening. The first one is 1 squared, 2 squared, 3 squared, 4 squared. So let's get on a roll here. We're up to 8 squared, right? Okay, keep going. Come on, you guys know your multiplication facts. Keep going. Thirteen times 13? Why guess? Use a calculator. 169. 196. And how about the last one we're going to do, the 15th one? 15 times 15? Okay, so by no means are these all the perfect squares. Those are just the first 15. Okay. Now, do you think there's more perfect squares or more non-perfect squares? There's more non-perfect squares. Okay. There are way more numbers that are not perfect squares. Way more. So what happens when you take the square root of a not perfect square? A big decimal that never stops and never repeats. What kind of numbers never stop and never repeat? What are they called? Oh. You got nothing? You've been taught this by me. What kind of numbers do not stop and do not repeat? They are irrational. Okay. Those are the kind of numbers that do not stop and do not repeat. You guys remember when we did the graphing and it was like a decimal that was a weird decimal on the x-axis? Those are irrational. Okay. Now, obviously, 0.25 is not irrational. That's just a quarter, isn't it? 0.3 repeating is not irrational. That's just a third, right? Okay, we're talking about these crazy looking numbers that never stop and never repeat. Okay, pi. Yep, that'd be one of them. So if I'm trying to do these things, are you going to want to write all of those decimals out? No, you're not. So we have to have a way so we don't have to write all those decimals out. Okay, we must be able to find exact answers without a huge decimal. We have to be able to find exact answers without a huge decimal, which means you have to be able to find perfect squares. You have to be able to find perfect squares, which is why we just wrote well, I shouldn't say all of them. We wrote the first 15 of them. Okay, are you ready? Yes? If you don't have your calculator out, you're going to need it unless you're really good at dividing large numbers. Okay, so here we go. We're going to start off nice and easy, and we're going to work it up to be a little bit more difficult. What is the square root of 16? Okay, that would be an exact answer, correct? Yes? Does it require an approximate answer? No, because it's just 4, right? You guys know what this NA means? Not applicable, not available, we don't need it, okay? So on all these problems, I'm going to go through and give an exact answer and an approximate answer, if I can. How about the square root of 144? It's 12, and then you see the negative in front of there, right, folks? So that's the exact answer. What's the approximate answer? There isn't one, because it's just negative 12. Now, let's talk about square root of 10. Is that a perfect square? It is not. Okay, so I need to ask you, is there a perfect square that can be divided out of 10? You have your perfect squares there on your paper, correct? Will any of those numbers divide evenly into 10 besides 1? Does 1 really count? No. 100, can I do 10 divided by 100? Can I split 10 into 100 pieces? No, I can't. The other way will work, right? 100 divided by 10. But do you agree there's nothing that will divide into 10 that's a perfect square? Yes. So the exact answer is just the square root of 10. That's exact. Now I want you to type it in your calculator, and I want you to give me the approximate answer. And I would like 1 decimal place, please. 3.2. Does everybody know where their square root button is on their calculator? Okay, wonderful. Let's go to the next one. I have the square root of 20. First of all, is 20 a perfect square? It is not. Is there a perfect square that can be divided out of 20? 4 is a perfect square, isn't it? Will 20 divide by 4? Yes, it will. So here's what happens, guys. If I take that 20 and divide it by 4, what do I get? I get a 5. That 5 is trapped under the radical because it's what's left when I take out my perfect square. Now, the perfect square was 4, correct? So if I want to get it out of the radical, I want to know what the square root of 4 is. 2. So this exact answer would be 2 radical 5. The 4 can come out, but when it comes out, I actually do the square root, which is 2. Is that okay? And then the 5 was not perfect. It stays underneath. Mhm. The 4 is what's perfect because the square root of 4 is just 2. Is that okay? And can you guys give me the approximation of this 1 decimal point? 4.5. Wonderful. How about the square root of 128? Is that perfect? It is not. So I need a perfect square that will come out of 128. 16 will come out. What does 16 come out as? No. Square root of 16 is 4. Is everybody in agreement with that? Now, what is 128 divided by 16? It's 8. But here's the thing. Isn't there another perfect square that can come out of 8? What perfect square can also come out of 8? 4. What does the 4 come out as? A 2. But folks, don't I already have a 4 out there? So I have to multiply it by that 2 that comes out. What is 4 times 2? 8. And what would be left underneath? A 2. Are there any more perfect squares that will come out of 2? No, there's not, right? Now here's the thing, guys. We did that in 2 steps, right? We divided out 16, then we divided out 4. You could have just divided it by 64. Isn't 64 a perfect square? And what is the square root of 64? 8. Is everybody all right with that? I don't care if you do 2 baby steps or 1 big step. It doesn't matter. You're still going to get the same answer. How about the decimal approximation here? 11.3. Okay. How about 300? Is 300 a perfect square? It is not. Is there a perfect square I can divide out of 300? 100. What does 100 come out as? A 10. Then what's left underneath? That 3. Nathan, does that make sense? Anything else that can come out of 3? No. What's the decimal approximation here? Okay, now I got some of you guys just looking at me like I'm crazy. Do you have questions for me? Yes. Because the square root of 100 is 10. When it comes out from under the radical, when we move it to the front, you do the square root of it. Okay. All right. Oh, I got another 300? Oh, I must have just wrote that one twice. Let's go to number 8 there. Is 891 a perfect square? It is not. Can you find me something to divide out of 891? It's got to be a perfect square. Which one? 9? What does 9 come out as? A 3? What was 891 divided by 9? Say it again. 99? Oh, I think another perfect square can come out. Hold on 1 second. We're going to go this way. You're doing it one big step, which is fine. How about here, guys? What else can come out of 99? What did you say could come out of 99? 3? But 3 can, but is 3 a perfect square? No. Guys, it's 99. 9. What does 9 come out as? A 3? But isn't there a 3 already out there? So 3 times 3 is 9. What's left underneath? An 11. So Andrew said 81, didn't he? Yeah, if you just divide it by 81, what does 81 come out as? A 9. Okay, so he did a one big step, whereas we did 2 little steps. Does it matter? No, it doesn't. What's the approximation here? 29.8. Okay, I'm going to get done with this slide, and then you guys can go. Okay, fair enough? 45, is it a perfect square? It is not. What perfect square can come out of there? What perfect square can divide into 45? 50 is not a perfect square. 15 is not a perfect square. 9 is a perfect square. What is the square root of 9? 3. And then what would be left there? 5. Does anything else that's a perfect square divide out of 5? No, it doesn't. What's the decimal approximation? 6.7. Does everybody understand the exact answer versus the approximate answer? Okay. Next one. 150. Is it a perfect square? No, it's not. What can I divide out of 50 that is, 150 that is a perfect square? What's that? 15 is not a perfect square. 25 is a perfect square. Folks, what is the square root of 25? 5, but isn't there a 4 already out there? So we're going to multiply them, and it makes negative 20. Now, what is 150 divided by 25? 6. Can you divide any other perfect squares out of 6? No, I can't. Can you give me a decimal approximation? Is it negative? Oh, I think it's got to be bigger than that. Negative 20, radical 6? Will it round up to 49? Is that okay for everybody? Nathan, are you okay putting that in your calculator? Okay. 112, is it a perfect square? No, it's not. What can I divide out of it that is a perfect square? 16. What is the square root of 16? 4. When you divide 112 by 16, what do you get? 7. Can you divide anything else out of 7? No. Decimal approximation? 10.6. Okay, last one. 360. Is it a perfect square? No. What can I divide out of 360? Oh, look at it, guys. It's 336. What is the square root of 36? What's left when you divide it out? No. 10. Can I divide any other perfect squares out of 100? Excuse me, out of 10? No. What's my decimal approximation? About 19? Okay, so those of you in band and choir, you may go. You need to get back on, though, and fast forward through this recording to get to this point again. Your homework will be posted to Classroom. You guys that are staying, you might get your homework done. We're almost done. Have a good day, guys. We'll see you tomorrow. I think there's only like 3 or 4 of you left, isn't there? I think there's just 3. Yeah, you can go ahead. All right, guys. I only have like 3 more left, and then you can get your homework. So number 13. First of all, is 12 a perfect square? No, it's not. Is there a perfect square that we can divide out of 12? 4? Ladies, be okay with this? What does 4 come out as? Nope. A 2? But there's already a negative out there, right? So this will be negative 2. And what is 12 divided by 4? 3. Now I just need a decimal approximation of negative 2 radical 3. All right, Mike's running the show here. You guys all right? Yeah. Okay. Now, the next one is a fraction, and it looks super scary. Okay. But when you do the square root of a fraction, you just do the square root of the top and then the square root of the bottom. You do it in like 2 separate pieces. So, is 49 a perfect square? Yeah, what is the square root of 49? 7. How about 900? Is 900 a perfect square? Now, it could be. I just didn't go up that high, did I? So you should try it. What's this? So it is a perfect square, isn't it? Is that okay? So this is just 7 over 30. Now, do you see the plus or minus sign in front of there? So we just need to drop that down. So don't be scared off by those radicals. Okay? They could just be perfect squares over there and it's just fine. Okay? Last one here. 216. Is that a perfect square? Don't think so. What can I divide out of 216 that is a perfect square? 36. Perfect. What does 36 come out as? A 6, but there's already a 5 out there, so multiply it and you get 30. What did you get when you divided 216 by 36? 6. Is there anything else that can be divided into that 6? Not that's a perfect square, right? Okay, so that's it for our exact answer. Can you give me the decimal approximation? Wonderful. All right, guys, how we doing? Is everybody okay here? Okay, so I actually have a physical worksheet to give to you guys. Everybody else is just going to have to copy theirs down from Classroom. Okay, so I will post, those of you that are listening to this, there should be an attachment of the worksheet. Okay, you'll just copy down the problems and do them. You 3, I'm going to actually give you that worksheet. Okay.